This lesson is solving quadratics by taking square roots. And our learning target is I can solve quadratics by taking the square roots. Okay, so first thing we're going to talk about, and we've already talked about this one time this year, and you're probably pretty familiar with it already, but quadratic equations are always going to look like they're in this form. Okay, so we have the ax squared plus bx plus c equals 0. These can be solved using the square root property. Okay, so here's what I'm going to do. If we just have like some number x squared equals a number, then these are the only ones that we're going to use the square root property on. So this is what it's saying. If x squared equals n, then x equals plus or minus the square root of n. And n is just a number, so just a placeholder. If that doesn't make sense, it's cool. We're going to use these same 3 steps every time. So number 1, we're going to isolate x squared. So we're going to make sure that x squared is the only thing on its side of the equation. Number 2, we're going to take the square root of both sides. Sometimes it's going to be a perfect square, which is really nice, and sometimes it's not, which we'll have something that we have to do in case that happens. And then the third thing we're going to do is simplify the radical. And if you'll notice, it says place plus and minus to indicate both answers. Because anytime you take a square root, you have a positive and a negative answer. And I'm actually going to change this up here again. Let me do this. If it looks like this, that's when we're going to use this method. So if it has the ax squared term and it has the plus a number term, so notice it doesn't have the bx equals 0, that's when we're going to use this square root property. So maybe that'll help. Okay, anyways. Alright, so notice we are going to solve the equation using the square roots method. And if you look at number 1, you have the ax squared term, and then you have the c term, and it equals 0. You don't have the b term, which is what you want it to look like when you're going to use this method. So this method is not going to work for every time. So if it has a plus number x in the middle of this, do not use this method. Okay, so the first thing we're going to do is isolate the x squared. So I'm going to highlight it just so you can see what we're trying to get by itself. Alright, so we got to get rid of that plus 64. And the way you undo subtracting 64 is you add it. And whatever you do to one side of an equation, you have to do to the other side. So you have x squared equals 64. Okay, so we've isolated x squared. That's what we wanted to do. Now, whenever we want to get rid of a square, the opposite of squaring both sides is to square root both sides. Okay, so when you take the square root of an x squared, that just becomes an x. Okay, and anytime you do the square root of a number, you have a positive and a negative answer. And you can type the square root of 64 in just a simple calculator, and it is a perfect square. It comes out to be 8. So anytime I say perfect square, I mean like 8 times 8 is 64. So when you take the square root of 64, you get a whole number. That's a perfect square. Alright, let's do another one. Alright, so notice it doesn't have that bx term. That's what we want. Okay, so we're going to isolate the x squared part. I'm going to highlight it. Anytime anything's being added or subtracted, that's what you want to get rid of first. So we're going to get rid of the plus 8 first. And the way we get rid of adding 8 is subtract it. Whatever you do to one side, you got to do to another side. Alright, we'll highlight the x squared again because we still don't have it by itself. So remember, the 7 and the x squared are being multiplied, and then the way you get rid of multiplication is divide. Whatever you do to one side of the equation, you got to do to the other. So x squared equals 1. So now you have the x squared not highlighted, you have it isolated, and you want to take the square root of both sides. We'll move over here. Whenever you take the square root of an x squared, it's just x equals. Whenever you take the square root of a number, you have a plus and minus, a positive and a negative answer. And 1 is a perfect square. The square root of 1 is 1. So I have two answers, positive and negative 1. Alright, let's do this one. We're going to isolate x squared. Whenever there's anything being added or subtracted, get rid of that first. So I'm going to get rid of positive 5 by subtracting. Okay. And then x squared is still not isolated, so remember 81 and x squared are being multiplied. I'm going to get rid of multiplication by dividing. So x squared equals 16 over 81. So don't freak out that it's a fraction, it's fine. We're going to do the same thing. We're going to take the square root of both sides. So the square root of an x squared is x equals, the square root of a number always has a plus and a minus. So if you'll think about this as being like the square root of 16 divided by the square root of 81. Both of these are perfect squares, which is really nice. So the square root of 16 is 4, and the square root of 81 is 9. So I have two answers, positive and negative 4/9. Okay, so let's try this one. This one's going to be a little bit different. We're going to isolate the x squared. We need to get rid of the plus 1 by subtracting. So we have 8x squared equals 16. We still don't have x squared isolated, so we need to get it by itself. So remember, 8 and x squared are being multiplied, and the way you get rid of multiplication is to divide. Okay, so you have x squared equals 2. Okay, so now we're going to get rid of that square by taking the square root of both sides. So anytime you take the square root of an x squared, it's x equals, you have a plus and a negative. Now, when you type in the square root of 2 into your calculator, go ahead and do that and let's see what happens. So when you type that in, you get 1.414213562, and it keeps going on forever. Okay, so we don't ever want to round whenever we're doing square roots. So what we try to do is try to simplify it. So this one is actually not going to be simplified because 2 is a prime number. So if you'll remember, a prime number is a number that only has 1 in itself as its factors. So there's nothing we can find that will multiply to give us 2 other than 1 and 2. Alright, so my final answer is actually going to be x equals positive and negative the square root of 2. Alright, I know that's a little confusing, but we're going to actually talk about how to simplify radicals. This one was a prime number, so we could not break it down any further. So it just stays the square root of 2. Never round when you're doing square roots. Okay, so let's look at this one. Same thing, isolate x squared. Anything that's being added or subtracted, get rid of first. So I'm going to get rid of minus 9 by adding 9 to both sides. So I got 2x squared equals 64. Okay, and then I still want to get that x squared isolated. So remember, the 2 and the x squared are being multiplied. The way you get rid of multiplication is to divide. So I have x squared equals 32. Okay? And then I got to get rid of this square by taking the square root of both sides. Okay, so the square root of x squared is x. It's going to equal plus and minus. You can type the square root of 32 into your calculator. It is not a perfect square. Okay? It's also not a prime number, so there are factors, so there are things that multiply to give you 32 besides 1 and 32. So what we want to do when we get these, we want to find the biggest perfect square is divisible by. The biggest perfect square, 32, is divisible by. So if you'll remember, perfect squares are like 1 times 1 is 1, so 1's a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. 5 times 5 is 25. Sorry, I hit the wrong button. 6 times 6 is 36. And then you can keep going on forever. So these are your perfect squares. And I'm just going to do an ellipsis because they keep continuing on forever. We want to find the biggest perfect square that 32 is divisible by. Okay, so you can check them on your calculator, but the biggest one I can find is 16. So here's what I'm going to do. I'm going to write it like this. X equals, I got plus, I got minus. The square root of 32 is the same thing as the square root of 16 times the square root of 2. Because 16 times 2 is 32. Alright, one of these is a perfect square. It's the square root of 16. And the square root of 16 is 4. So here's how I'm going to rewrite it. X equals plus and minus 4 square roots of 2. I don't do anything with the square root of 2 because remember that's a prime number. It can't be broken down any further. So that is how you would write the square root of 32. You would write it as 4 square roots of 2. It's a little confusing, but it works the same way every time. So whenever you have a radical, if it's a prime number, it doesn't break down any further. If it's a perfect square, then you put that answer. But if it's not a perfect square and it's not a prime number, you have to find the biggest perfect square it's divisible by. Alright, we're going to do another one. So you should be pretty good from right now. Alright, so we're going to get rid of plus 3 by subtracting. So I got 9x squared equals 108. I'm going to get rid of the 9 in front of the x squared by dividing both sides by 9. So x squared equals 12. I'm going to take the square roots of both sides. The square root of x squared is x equals plus and minus. 12 is not a perfect square. It's also not a prime number, so I'm going to have to break it down further. So remember, here are your perfect squares. These are just some of them. I want to find the biggest perfect square that 12 is divisible by. So the biggest one is going to be 4. So what I'm going to do is I'm going to rewrite it. Plus and minus. The square root of 4 times the square root of 3. So remember, 4 times 3 is 12. That's why I'm writing it like this. One of these is a perfect square, and that's the square root of 4. So x equals plus or minus. Remember, the square root of 4 is 2, and then 3 is a prime number, so it stays in the radical. So my answer is x equals plus or minus 2 square roots of 3. Okay? This one's a little bit different, but it works the same way. We want to isolate x squared. Okay? Anything being added or subtracted you want to get rid of first. So this one looks a little different, but it's actually pretty much the same. We want to get rid of a positive 4. The only way to get rid of positive 4 is subtract. So just make sure you don't do nothing like drop the negative. I do that stuff all the time. It's just easy mistakes. Okay? And then I still want to get x squared by itself. So I'm going to divide both sides by negative 3. Okay, I'm going to take the square root of both sides. So the square root of x squared is x. Then we have equals plus or minus the square root of 27. 27 is not a perfect square, but it's also not a prime number, so it can be broken down. So I'm going to write out the perfect squares. Okay, and I'm finding the biggest perfect square that 27 is divisible by. 9 is the biggest perfect square it's divisible by, so I'm going to rewrite it. Plus and minus the square root of 9 times the square root of 3. And you can take the square root of 9, it's 3. So my final answer is going to be plus or minus 3 square roots of 3. So hopefully this is making sense. So I want you to try this one. I want you to pause the video and I want you to try it. If you get stumped, then push play. Or if you finish, you can push play and see if we got the same answer. So pause the video in 1, 2, 3. Alright, so I want to isolate x squared. I'm going to get rid of the plus 10 first. Alright, I got rid of 10. I still need to get x squared by itself. So I'm going to get rid of the 5 in front of x squared. So I got x squared equals 60. Now I'm going to take the square root of both sides. So x equals plus and minus the square root of 60. 60 is neither a prime and it's not a perfect square, so I need to find the biggest perfect square it is divisible by. Okay. So 4 is the biggest one it's divisible by, so now I'm going to rewrite it. X equals plus and minus the square root of 4 times the square root of 15. Okay, so I know 15 is not a prime number, but you can't break it down any further. Alright, so I can take the square root of 4. So I have x equals plus and minus 2 square roots of 15. So if you got the same answer, yay! If you didn't, maybe you can find your mistake and fix what you're doing wrong. I'm going to give you one more to try. This one has a scary fraction in it, but it's okay. You can do it. I want you to pause the video in 1, 2, 3. Okay, the first thing I'm going to do is get x squared by itself, and I'm going to do that by getting rid of the 1. Okay, now I need to get rid of the negative 1/2. So you can divide both sides by negative 1/2, or you can multiply both sides by negative 2. Either one is going to give you the same thing. If you're doing negative 40 divided by negative 1/2 in a calculator, make sure you put parentheses around that fraction. Then I'm going to take the square root of both sides. Okay, 80 is not a perfect square. It's also not a prime number. I need to find the biggest perfect square that it is divisible by. I just skipped number 9. I don't know why. It's 9, 16, 25, 36, 49, blah, blah, blah. The biggest perfect square that 80 is divisible by. So I got 16. Alright, so x equals plus or minus the square root of 16 times the square root of 5. And then I know that the square root of 16 is 4, so my answer is x equals plus or minus 4 square roots of 5. 5 is a prime number, can't be broken down any further. Alright, so there's some problems to try on haiku. You can always work together. You can send me a message if you need help. But y'all are pretty smart, so I think you're going to be fine. And make sure you understand how to do this, because we will use this later when we're going over the quadratic formula. And we'll also start to do the square root of negative numbers. Scary. Not really. Okay, bye.